analysis of variance. What is the need for studying this analysis of variance? Suppose the question is given to be that suppose 3 dying formulas for curing a glue are studied and following times observed. That means you are given formula number A, formula B, formula C, and corresponding to this the time for dyeing were noted. So it was 13, 10, 8, 11 for the formula A. For the formula B it was 13, 11, 14 and 14. And for the formula C you were given 4, 1, 3, 4, 2 and 4. It is 11 here, and here also we have 8. Okay, so this is what you are given. So you are to test the hypothesis at 5% level of significance, right? So this is the question. Now can you test it using the t-test? T-test for one sample, what was the formula? T was equal to x bar minus mu divided by s divided by square root n, where what is this s? S is the standard deviation for the sample, mu is the mean of the population, and this x bar was the mean of sample, right? For two sample, what was how do you calculate this t? T was calculated by x1 bar minus x2 bar minus mu1 minus mu2 divided by s into square root of 1 by n1 plus 1 by n2, where what is this s? S is calculated by the formula summation xi minus x bar whole square plus summation yi minus y bar whole square divided by n1 plus n2 minus 2. So this is how you calculated this for two sample. So this was the value of s square. Now in this case, how many formulas are given to you? You are given 3 formulas, A, B and C. So that means here more than 2 samples are given to you. So if we are to apply the t-test here, so how can we apply that? We are to compare time, that the mean time for formula 1, is it equal to mean time for formula 2, or is it mean time for formula 3 C, right? Or we are to determine out of the formula A, B and C which one is better. So this is what we wanted to see. So here our null hypothesis H naught, that would be that all the samples means that is equal. So the sample mean of first is equal to second is equal to third. That means there is no difference between their means at this level of significance. For the alternative hypothesis here, what we can say? We can say either the mean of first A and B they are equal, but for C that is not equal. For first and second they are equal, but not equal for third. And for similarly we can say the mean for A, B and C they are not equal at all. So these 3 conditions could be there. So either what you can do, you could apply the 2 sample t-test here. How many times? 3 times. How? In the first case you consider your H naught to be mu A is equal to mu B, and in that case you consider H1 as mu A not equal to mu B. In the second case you could consider H naught is equal to mu A is equal to mu C, and in the third case you could consider H naught is equal to mu B is equal to mu C. So this is how you could compare these using the t-test applied 3 times. So that would be inconvenient. So for that we require, whenever you have 3 samples, so at least when we have at least 3 samples, then we use this ANOVA, right? So what are the assumptions of using ANOVA? That means when can you use ANOVA? So first thing is that whenever the population follows normal distribution, in that case you could apply this ANOVA. And here the number of elements, they should be greater than 30. Second, each sample is drawn randomly. This is the second condition. And the third condition is that the population from which the samples are drawn have identical mean and variance. The population has identical mean and variance. So this is the assumption. So how do we solve this question? Now here first of all we will calculate according to the given formula, and these are your observations. So according to the given formula and observations, we'll calculate the total sum total, right? So we'll calculate total sum, which is represented by Ti, and it is obtained when you add up all these quantities. So when you add 13 plus 10 plus 8 plus 11 plus 8, so it would be 9 plus 8, 17 plus 3, 20, to carry, we have 50. Similarly for second, when you add up all these, you will obtain 52 here, and when you add up all these, so it would be 18. So this is the Ti, this is for for formula 1, this is for formula 2, formula B, this is for formula C, and then we can calculate the grand total. Grand total is calculated when you add up these quantities, all the Ti's. So you obtain 120 here. So this is the grand total. Now this is what you were given in the question. The next step is to set up the null hypothesis H0. How can you set that? In this case, we wanted to check whether which of the formula is better, right? So we want to check here which formula is better. So for that, we are assuming the null hypothesis as mu A equal to mu B is equal to mu C. That means all formulas are same. And so our alternative hypothesis in this case would be at least one of the sample mean is different. Right? And here we have n as equal to 15. The correction term C is calculated by calculating G square divided by n. What is G? G is your grand total. This is the grand total. So it is obtained from this table, and whose value we have calculated to be 120. So we have its value as 120. So its square divided by the value of n, that is 15. So we have the value as 960. Okay, so this is the correction term. The next step is to make the ANOVA table. Next, to make ANOVA table. Here in ANOVA table, every time we will make these columns. So first of all, we will write sources here, then we will write degrees of freedom, and then we will write SS, that is the sum of square, right? Its meaning is sum of square. Then we write MSS. What is that? This is mean sum of square. And then we will write here F ratio. So in this ANOVA table, we'll use F test. So according to this, how many sources are there with you? Here you will write what is given to you. You are given formula. 3 formulas are given to you. And here you will write error. And then you will write total. So what this is the degree of freedom. How many formulas are given to you? In total we are given 3 formulas. So your degree of freedom always is n minus 1. So here we have 3 minus 1. So our degree of freedom is equal to 2 here. Right? And because your n, capital N, is equal to 15, therefore the total degree of freedom would be 15 minus 1. So it would be 15 minus 1, or I can write it is n minus 1, right? So this is equal to 14 here. And what is the error quantity? This is obtained by calculating 14 minus 2. So it is equal to 12. Because you wanted to add this term and this term so that you obtain the total as 14. And then you will calculate sum of square between the formulas. And then you will calculate the sum of square for total. And then you will calculate the sum of square for the error quantities by subtracting these 2 values. So first of all, let us calculate sum of square for formulas. Sum of squares for this quantity formula. So it is calculated using the formula summation ti square divided by ni minus c. Now what are these terms? You know, ti is the total which we have calculated. Ni, what is that? It is the number of observations given for formula 1. So here ti represents the sum total for each formula. Ni represents number of observations for each formula, right? And what is C? C is the correction term. We already have calculated this correction term. So we can calculate this for formulas. So this is calculated sum of square SS for formulas. It is calculated as TA by NA minus C plus TB divided by NB minus C. Okay, the summation is not varying over C. It is only varying for I upon Ni. So we have for the first formula this term, for the second formula, and for the third formula minus C. So this is what you have. Now what is TA, TB and TC? Let's go back to our table. The value of TA is equal to 50 here. The value of TB is 52. The value of TC is 18. right? And how many observations are available here? For formula A, we have 1, 2, 3, 4 and 5. So the value of NA would be 5. The value of NB would be 1, 2, 3 and 4. So NB is 4 and N3 is 1, 2, 3, 4, 5 and 6. So we have total 6 values here. So that means we can write down the values here. So it would be equal to, so TA we calculated to be 50, TB we calculated to be 52 and TC we calculated to be 18 divided by NA is 5 observations, NB is 4 observations, yes, and NC is 6 observations. These are given to, and the corrected term here is given to be, here we have calculated to be 960. So this is what we have, minus 960. So finally this term, and moreover we have had the square of these quantities. So when you calculate and solve this, it would be equal to 270. So this is the value that you got, and you will write it over here. This is equal to 270 here. Similarly, you will calculate it for total. The formula for calculating sum of squares for total is, next we will calculate sum of square for total. It is calculated by using this summation xij whole square minus c. First summation varies over I and it varies over j. Now what does it mean? It means this xij means every observation that is given to you. So this become equal to, now here you are to write down the square of the given data values. So first data value is this 13, second is 10, third is 8, next is 11, next is 8, next is 13. So for every value, every 15 value, you have to write down this formula for sum of squares, right? So we will have 13 square plus 10 square plus 8 square plus so on, right? This is for first formula, then we'll write for second formula. For second formula it would be 8 square plus 13 square plus, let me write down everything. So we have 13 square plus 10 square plus 8 square plus 11 square plus 8 square. This is for formula first. For second formula we have 13 square plus 11 square plus 14 square plus 14 square plus, for the third formula we have 4 square plus 1 square plus 3 square plus 4 square plus 2 square plus 4 square and minus c. What is c? C we calculated to be 960. So minus 960, this comes out to be 302. So this is the value which you will write here for sum of square total. So this is 302. Now this value is obtained when you subtract 270 from 302. So this value is available to you as 32, right? So this is the quantity here. So that means when you add 32 and 270, you obtain 302. Next we are to calculate the mean sum of squares. So how do you obtain the mean sum of squares? The mean sum of squares is obtained when you divide SS. This is obtained when you divide SS by degree of freedom. So in this case, what is the value of SS? It is 270. The value of degree of freedom is 2. So you obtain this value to be 135. And in this case, the value is 32. You divide that by 12. You get the value as 2.667. So this column, this represent. So here this column, this represents the variance between the samples. So we are to calculate F ratio. By calculating F ratio, we will make our decision. So F ratio is calculated by dividing this term with this term. So that means we will divide 135 by 2.667. This come out to be equal to 50.6. So this is our F ratio. Now depending upon S ratio, we'll make a decision. So this is our calculated value of F for 5% level of significance. Now we will look at the table to determine what is the F value at 5% level of significance. So to make a decision, we will look at the value of F calculated at the degree of freedom at 0.05% level of significance. This is the level of significance. And this is the degree of freedom. So if you look at the table, from table of F values, the value of F for 2, 12, 0.05. Now this is the level of significance, and here we have degrees of freedom. If you look at your table, your degree of freedom for formulas is 2 and for error it is 12. So you will look at the degrees of freedom F2, 12 at 0.05% level of significance. From table, this value comes out to be equal to 3.89. And this value is directly given to you in the exam, right? So here the value that we obtained, this is equal to 3.89. And our calculated value, F calculated, that is equal to 50.6, right? This we have just calculated in the given table. It is 50.6 F ratio. So that means in order to make a decision, how do we make a decision here? We'll make our distribution like this, the normal distribution. So this is your 0 level, and because at 5% level of significance, this is our critical region. If your value lie here in this critical region, we will reject our null hypothesis, and if your value lie in between the region except critical region, we will accept our null hypothesis. So in this case, this value according to table is how much? This is 3.89. This is the F tabulated value at 212 degrees of freedom at 5% level of significance. So now our value is 50.6. So it would be somewhere here, right? So that means we are in the critical region here, because your F calculated value is not less than F tabulated value, right? This is your F tabulated value. So that means in this case we will reject our null hypothesis. Why? Because your value lies somewhere here. This is your F calculated value. So it lies in the critical region, because F calculated value lie in the critical region. So if we reject a null hypothesis, therefore we will say that we will accept our alternative hypothesis. So H1 is accepted. So therefore we say either one of the formula is not equivalent. So that means at least one of the formula is good. So this is how you solve this question. This method of calculation is known as one-way ANOVA, analysis of variance, right? And there is another name for one-way ANOVA. We can write this to be completely randomized design. So in short, this is known to be CRD, right?